Okay, so this is the maths prediction for class test 2 for maths 130. Now, in this prediction, it's different from my other prediction as it gives basically in words what's coming out. Now, I did this because if something doesn't come out, let's say in here, then another one will come out. And if that doesn't come out, another one will come out. So, no matter what happens in this section, something over here has to come out. So now, not like when I give you an equation, if that doesn't come out, it doesn't come out. But now, if something doesn't come out from here, you got all these to come out. Okay. Also, it's a good guide to know how marks are weighted and know what sections you have to learn in those sections. Okay, starting with question 1, which is logic. Now, logic is also it carries quite a bit of marks, 10 marks. So basically, construct a truth table given with the information is the most popular one they give you, right? They give you like a whole statement, like a compound statement, and they say like to get the answer for it, do a truth table. Then statement given, write the inverse, contrapositive or converse. This means when they might say P implies Q, and then you write all these in the inverse, converse, contrapositive. Or they might do it different. They might give you statements and then you have to do it, like actual word statements. The next one, truth value of two statements will be given. So they might say P implies Q is false. Then you know the only way that happens is when P is true and Q is false. So now when you answer questions like P or Q, you know what P's value is and you know what Q value is, and then you make the decision. Then know how to solve, show statements are tautology or contradiction. Remember, tautology is when you get your statement to be all true. So true, 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 true. Contradiction, all false. So you must know how to show that using a truth table. So question 2 is proofs. Now proofs is very common. It 100% comes out. They most likely will give you 2 proofs. Now 2 ways they can do this. They can give you one big proof for like, let's say 5 marks, and then one small proof for like 3 marks. Or they can give one big proof for like 6 marks, and then 2 small proofs, like very, very small proofs for like 1 mark each, sometimes that. But most likely it's 2. One is 5 marks and one is 3 marks. Now the big 5 marks one, sometime most probably, is proof by contradiction. Okay? And then proof by contrapositive, direct proof, those are most likely like 3 marks. Direct proof is the most common, proof by contradiction is the most common. But learn contrapositive and vacuous and travel proofs. If this comes out, it'll come out for 1 mark each or 2 marks each. But very thing. And also note that you won't get to like what proof to learn. I mean, what proof to apply in the exam. You will get a statement and you have to decide, okay, what proof I'm going to use from here. So that they won't give you, okay? So you have to understand. Question 3. So you're going to get one mathematical induction question, and that question from mathematical induction comes from over here. So they might give you a proof by divisibility of an exponential or proof by a series of formula. Look at the past papers. Proof by divisibility of an exponential, they might say prove that 2 times 5 to the power of n is divisible by 4, for example. Then you have to prove it. Then they might give this where they give you like a series, a number pattern is equals to n times n plus 1 over n. So that's like the formula, but you have to prove it. So that's 2 ways mathematical induction is tested. And there's only one from these 2 ways. Then sigma notation. Looking at the past papers, the only way they test sigma notation is to give you a pattern, number pattern, and you have to make a sigma notation for it. Even if they change it, you'll know how to use it because it's simple how you make a sigma notation. Next one, functions. Okay, so these ones carry the most marks. Functions. Now any function question they can ask literally anything, right? Composite functions. No composite functions. It is very, very common. They give you like what's f composite g and then work at the domain. Very, very common. Domain and range for all functions you just need to know, right? They might ask what's the domain or range for that function, this function. Class test 1 was a multiple choice. Who knows? They might put this in a multiple choice. Not a bad idea, but again I don't think so. Whether function odd or even or neither. Simple. It comes out, it came out last year actually, so I don't know if this will come out, but common. Shifting and reflecting, very important. Know what's shifting, what's reflecting, how it's done. Piecewise function sketching. Yeah, piecewise function sketching might come out, might not come out, but it's something to take note of. match graph to equations comes out for quite a bit of time. Basically, they give you a graph and they put all graphs in this one graph, so like a set of axes, and they basically tell you to match the equation. So functions, yeah, all these can come out. You just have to just know all of this, because anything can come out from here. Question 6 and question 7 is limits. Now limits, proving a limit by definition, and what I mean is this. So if you go to your book, there's a theorem of how to prove a limit. It's called the delta epsilon theorem or something like that. You'll see that, like a funny kind E letter thing and stuff. You got to prove it. There's like a concrete definition. You just memorize it, right? Then, or by substitution, they'll give you like a piecewise function and they'll say, okay, does the limit as x approaches to exist? So the piecewise function, basically you have to look from the left limit and make the left limit, see if the left limit equals the right limit. If that is the case, then the limit exists. Evaluating limits, no property. So here they'll tell you what's the limit as x approaches to x squared minus 4x minus 2, and you basically have to get to an answer. So yeah, there's lots of different properties of it, dividing, times, plus. Once you see it, you'll get a pattern. It's actually not hard. So you must know this, very important. Also know your sign and stuff. So sometimes they put any limits, like they'll put what's the limit as x approaches 0 to cosec, and you have to work that out. Then know how to find the left versus right hand limits. I told you that's important because this over here is very important for evaluating limits. Right hand, because remember, if the left hand side is not equal to right hand side limit, then the limit does not exist. So also anytime you get limits right, and you get limits such as a fraction, and in the fraction in the denominator they got an x, most likely of the time that's not going to have any any limits. The limits won't exist because that's a parabola. So one line you'll see goes to infinity and the next line goes to negative infinity. Because anytime like a fraction is a parabola. Not a parabola, hyperbola. You know hyperbola where you got the two asymptotes and it goes like this and it goes like this. Yeah, so most likely that's don't have any limits, right? Then sandwich theorem. A sandwich theorem is just a theorem you need to know. Yeah, sandwich theorem is just a theorem you need to know. Just revise that. Then infinite limits, same, just know what's an infinite limit, not to apply the infinite limit. Also, we know left hand versus right hand limits. They'll give you evaluating limits, but somehow you have to use left hand, right hand limits to get a limit to say that it does not exist. I told you, look for a fraction where denominator is 0. Denominator got x. It's called bottom heavy when the x is in the denominator. Most likely that has no limits. Okay, so lastly, continuity. Very important, they ask you this all the time. Know 3 conditions to check a function continuous. Now, I came at last year, so probably won't come at this year, but if you need to prove continuity, you need to know these 3 conditions. If they ask you to prove something, you need to know. So regardless, you need to know these 3 conditions. Because if they ask to prove that a function is continuous, you have to use these 3 conditions in your answer and show that they all satisfy each other, okay? One of the conditions is, let's say a is an x value. So first condition, f of a exists. Second condition, the limit as x approaches a of f of x, a function, exists. And if both of them are equal, then it is continuous, right? Identify if a function is continuous at an x value. So over here there's 2 ways you can ask this. A common way, they put a piecewise function, and in the piecewise function there's 2 equations, and basically both of those equations got a there and b there as unknown. So you have to use your continuous knowledge to find a and b. Basically you have to, it's the same as this, right? Where you basically putting in the x value in the equation and making that equation equal to the second equation by putting the same x value. So that's how you make it continuous. Then identify a function continuous at an x value. Yeah, same thing. I use the 3 conditions. And know the intermediate value theorem. Now, intermediate value theorem is common. They asked you this quite a bit. Asked this past paper, so it might not come out. But at the end of the day, something you need to know, because they might not ask you directly about intermediate value theorem. They might give you a question which needs an intermediate value theorem, so know that. Okay, so that is a maths prediction for the maths classes paper 2. It's a different prediction, as you can see. Instead of equation, there's words. So at the end of the day, if the one doesn't come out, others will come out, and no matter what, everything in this paper here might come out. So yeah, that's the prediction for this test.